We now discuss the solution of a problem from linear algebra. The problem is on matrices. This question has appeared in CSIR UGC NET examination held on 26th November 2020. It is from the section C, and this question carries 4.75 marks. The problem is, let P be a square matrix such that P square is equal to P. Which of the following statements are true? Options. First option, trace of P is an irrational number. Option 2, trace of P is equal to rank of P. Option 3, trace of P is an integer. Option 4, trace of P is an imaginary complex number. Matrices of the type P square is equal to P are called idempotent matrices. The question asks for what is trace of an idempotent matrix, and the options 4 are given. Before going into the discussion of the solution of the problem, let us recall some of the results on idempotent matrix. A square matrix A is said to be an idempotent matrix if A square is equal to A, and it is also called a projection matrix. We have the first result. The first result is the eigenvalues of an idempotent matrix are either 0 or 1. The second result is every idempotent matrix is diagonalizable. Let's get into the discussion of the solution of the problem. We have P an n by n matrix such that P square is equal to P. That is, P is an idempotent or a projection matrix of order n. It is known the eigenvalues of an idempotent matrix are either 0 or 1. Now, trace of P is equal to the sum of the eigenvalues of P is equal to a non-negative integer. Why? The eigenvalues are either 0 or 1. When they are added, we'll get a positive integer, but at times if all of them are 0, you might also get a 0. Therefore, it is a non-negative integer. So let's look at the options. Option 1, trace of P is an irrational number, which is not true because it is a non-negative integer. And option 4, trace of P is an imaginary complex number. This is also not true. So therefore, the option 1 and 4 are not true. And option 3 is the trace of P is an integer is true. So the option 3 is true. It is known that every idempotent matrix P is diagonalizable. It means P is similar to a diagonal matrix. That is, P is conjugate to a diagonal matrix. That is, there exists a non-singular matrix Q such that Q inverse PQ is equal to D, where D is the matrix consisting of the eigenvalues of P along its diagonal. D is a diagonal matrix with the eigenvalues along its main diagonal. So there exists a non-singular matrix Q such that Q inverse PQ is equal to D. Now Q inverse PQ is equal to D will imply rank of P is equal to rank of D, because the P and D are conjugate and P and D are similar. Similar matrices will have the same rank. Therefore, rank of P is equal to rank of D. This implies rank of D, that is the rank of the diagonal matrix, will be the number of ones on the diagonal of D. So the number of ones on the diagonal of D. The number of ones on the diagonal of D is the trace of P. So the trace of D, and this is same as the trace of P. So rank of P is equal to trace of P. So what we have seen, option 1 is not true, option 3 is true, option 4 is not true. Now the option 2 is true because the trace of P is equal to the rank of P. So thus our final, so the option 2 is true. Our final answer is options 2 and 3 are true. So that is the discussion of the problem on idempotent matrices from the section linear algebra. I hope that you have understood the solution, and I wish you all the best. Thank you.